Hello, students. I've taken the time to explain how I approach an Olympiad. So I've solved all of the problems for Math Olympiad 2. The solutions are posted. You can look through them online in the resources section. They're in a PDF file. But you can watch this video where I kind of walk through my thinking on how I solved all 5 of the problems. And maybe that you'll find that helpful just to listen to me talk through my solving of the problems. You'll notice that I solve them in 30 minutes, but I talk and talk and talk, and I solve them multiple ways. So you really do have plenty of time, and none of you really run out of time when you're on these Math Olympiads. So that's really good news. So go ahead and listen to whichever solutions you want. Fast forward, delete, whatever you want to do. Utilize this video as you wish. Anyway, here goes. Let's work through these problems. Okay, so this is how I think about it, and maybe you think about it differently. And there are a lot of ways to do a number of these problems, but let me just walk you through kind of how I have done these problems. Okay, so we say compute the sum of all 9 two-digit numbers with ones digit of 16. First of all, you have to kind of think through, what does that mean? Well, all 9 two-digit numbers with a ones digit of 16, with a ones digit of 6, sorry, is 16, 26, 36, and 96. The way I broke this down further, and you can do this a lot of different ways, but if you just think of this kind of as a what they call number theory problem, you can kind of think of it as you can think of this as 10 plus 6, this is 20 plus 6, dot, 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 all the way up to 90 plus 6. Okay? And then if you do some rearranging of the numbers, you basically get 10 plus 20 plus 30 plus 40 plus 50 plus 60 plus 70 plus 80 plus 90. And then you have how many 6's left over? You have 6 plus 6 plus 6 dot, 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 plus 6. And you have 9 of these. Okay, so now this becomes a little bit easier of a problem. So if I have to add up all of the numbers from 10 to 90, remember, I mean, you've probably learned this trick before. You basically you take the outside ones, like this, and then you have, 10 plus 90 is 100. 20 plus 80 is 100. 30 plus 70 is 100. 40 plus 60 is 100, and then you have a 50 left over. So that's what? That's 450. And over here we have 9 times 6, which is 54. So 450 plus 54 is 504. Now, you could have done this, you could have just added the numbers up, because there's a lot of time on this test. So feel free to just, add them, write them all down, and then just add them up. Add them up. And that's fine. You have 30 minutes. No one runs out of time on this test. They give you tons of time. So that's the first answer, is 504. There's a couple of other number theory ways to do this problem, but we'll just leave it at that. So let me get rid of this so we can create some more space. Okay, now this next one involves a little bit more advanced number theory. Now again, the easy way to do this, you just say 45 times 123, and then you do 246 times 30, and then 369 times 15, and you do all your multiplication, and you get 5, 5. I'm not gonna do this out. 7, 3, 80, and then 5, 5, 3, 5. And if you add all that together, you get 18,450. Now, this is the answer, right? And you can do the multiplication like this. I'm going to go through some advanced kind of number, called number theory or number sense ways of doing this. And you may not have learned this in math class, but let me just go through it. And you might learn something. You may follow. If you don't follow this more complex explanation, don't feel bad. You may not have learned this in 5th and 6th grade. In fact,
You probably didn't. But this'll involve the commutative and associative properties of multiplication and addition, and just kind of watch what happens. This here is the same thing as 123 times 15 times 3. 246 is 123 times 2 times 30 is 15 times 2. You'll see why I'm doing this in a second, because you may have seen that there's kind of a 15 hidden in here, a 15 hidden in here, and a 15 hidden in here. And it's going to make our problem a little bit easier to solve. And this has a hidden 123 in it, and this has a hidden 123 in it. So 369 is 123 times 3, and 15 is, again, 15 times 1. Now, I'm going to rewrite this again a little bit one more time and go 123 times 15. And now I'm going to say times 3. Plus, and you can rearrange these because this is here, this is all multiplication. So I'm going to move this 15 in front, and I'm going to get 123 times 15 times 2 times 2, right? That's just this rewritten like that. You can multiply numbers in any order. I'll do it again. 123 times 15, and what's left over? Times 3 times 1. Okay, so this is equivalent to this, this is equivalent to this, and this is equivalent to this. Those are all equivalents. Now I'm going to do one more trick, and I'm going to do what they call distribution. Now, if I have 3 of these up here, and right here I have 4 of these, and here I have 3 of these. Again, this might be, don't worry if this doesn't make sense, but if it does make sense, this is pretty cool. Well, let me just do this multiplication real quick. 123 times 15. So 123 times 15 is 1845. So this is 1845 times 3 plus 1845 times 4 plus 1845 times 3, right? I haven't done anything terribly tricky yet, just kind of regroup some of my numbers. Now, if I have 3 185s, and I have 4 185s, and I have 3 185s, right? I have 10 of them. I have 1845 times 10. I have 3, 4, and 3. And so that 1845 times 10 is 18450, right? If you multiply anything by 10, it's just, you just add a 0 to the end of it. So this is kind of an advanced number sense kind of question. But again, you could have, if you just wanted to, is just done your 3 multiplications and add them together, and you would have gotten the 18450. This is probably a high school way of thinking about the problem, but some of you may see it. And so that's why I just wrote that down for you. But if you don't get it, again, don't worry about it. Now let's do this. Nat is thinking of a 4-digit number. Okay, this one might be a little bit easier. I don't know. We'll see. A 4-digit counting number. So let's just get 1, 2, 3, 4. The 1,000 and hundreds digits are the same. So these are the same. These are the same. The sum of all digits is 28. So if I add them all together, I get 28. And it's an odd multiple of 5. So what do we know? If it's an odd multiple of 5, all multiples of 5 end in either 0 or 5. But if it ends in 0, it's even. So we know the number has to end in 5. So exactly 2 digits are even. So what is Nat's number? Well, let's see. If these are the same, if one of them's odd, then the other one's odd. And then we can only have one even digit. So it can't be, so these have to be even, because if this was even and this was even, then I'd have 2 digits that are even. And then this one has to be odd. Okay. All right, so now we're getting pretty close. So if we have to have 2 even numbers and odd in a 5, let's see, and we have to add all the digits together to be 28. Let's see, what are our possibilities? We could have 2, 2, 5, but then to get up to 28, because 2 plus all these numbers together have to equal 28. I can't get to 20. I can't add them together and get to 28 because this number would have to be 19. So that's too big. So that doesn't work. And if I do it with 4, we're going to have a problem also. So let's see. So what do we have left? We can do 6, 6, or 8, 8, 5. Let's see. 6 and 6 and 5. That's 17. 6 plus 6 plus 5 is 17. And so this number would have to be 11, but you can't have an 11 digit there. So it has to be 8, 8, 5. And let's see, if we take 28 minus 8, we get 20. Minus 8 is 12. Minus 5 is 7. So that has to be our number. So 8 plus 8 is 16. 16 plus 7 is 23. And 23 plus 5 is 28. So this is the only number that satisfies all of our conditions. The 1,000 and hundreds digits are the same, yes. Add up all the digits, it's 28. The 4-digit number is an odd multiple of 5 because it ends in 5. So the number must be 8875. All right, so that's 1, 2, and 3. Now this next problem is a little tricky, but a player can move. So let's see, a player can move from point to point only in a direction that includes a downward motion, slanted or not. And how many ways can you go from the top to the bottom? So let's think about what that means. I got to go from the top to the bottom, and I can only go down or slanted with each move. So I'm going to try a couple different patterns here. So I can go down, down, down. This is one way to do it. You can go down, 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 down. Okay, so these are the kinds of ways that we can move to get to the bottom. We can go this way. Well, once you go this, you can go this way. You can go this way. You can go this way, this way. So it's kind of hard to count up all. They're not making this easy for us, but let's see if we can come up with a strategy for getting to the bottom. And this is the strategy that I thought of. And again, it may not be the one that you thought of, but I said, well, let me start at the bottom. Let me think about this. So if I'm coming from any one of these 3 dots here, that's what I'm going to analyze first. If I'm here, there's only one way to get to the bottom from here. Okay? Similarly, if I'm here, there's only one way to get to the bottom, and it's straight down, 1. And if I'm here, there's only one way to get to the bottom. So that's easy enough. So why did I get to that? Well, let's see. Well, because I'm going to come my idea is to come all the way back up to the top and look at every point and see if I can make heads or tails of the number of ways to the bottom. So I'm not making complete sense yet. I know that. But watch what happens when I look at this next set. We start, I think, to make some sense of Mr. Lipscomb's strategy. So if I'm here, how many ways there are to the bottom? Well, there's only this way, and this way says there's only one way to the bottom. So if I'm here, there's only one way down, and that's this way. Okay? All right, let's think, what if we're, okay, if I'm here, how many ways are there to the bottom? Well, there's only one because I can only go through this dot here. Right? So there's only one way. If I'm here, I have to go this way, and that's through that one dot. Okay? Now that's all simple and good enough, but once I'm here, it starts to get kind of interesting because there's actually, I can go this way, and if I go this way, there's only one way down, but I can go this way. And if I go this way, there's one way down. So if this way, there's one way down, and this way, there's one way down, then from here, there's two ways down. All right? And again, let's make sense of that, right? I can go, let's switch to purple. So if I'm here, I can go this way or this way because there's one way down this way and one way down this way. So wait, this is kind of cool. I can start to see that there's a way of adding. If I go down, I just add the nodes below me. So if I'm here, there's one way down because there's only one node there's only one way down from that node. And if there's here, there's only one way down through that node. Okay? Starting to make sense? Now, what if I'm here? If here, there's only one way down, because there's only one way down. Here, there's one way down. And likewise, over here, there's one way down. Here, there's also only one way down, because if I go this way, I come to this one node. But here, if I go this way, there's one way down. But if I go this way, there's two ways down. So from here, there's three ways down. One that way and two that way. Okay, let's do it from here. Here, if I go this way, there's two ways down. If I go this way, there's one way down. So there's a total of three ways down from here. All right, from here, there's one way down that way and one way down that way. So here there's two ways down. Here there's only that way down, but that gives you three ways down from here. Now from over here, let's see, if I go this way, there's one way. If I go this way, there's three ways. If I go this way, there's three ways. So going from this thing, there's 7 ways down. And if I'm here, then there's, if I go this way, there's 7. If I go this way, there's 3. And if I go this way, there's 2. So 7 plus 3 plus 2 is 12. So there are 12 ways down. If you wanted to, you could have just, there's another way to do this. And the other way to do this is to just label all the nodes and just count them. So you could have said, well, this is A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R. And I could have said, okay, well, one way down is A, B, E, J, O, R. And I'm only labeling them this way just so I keep track of them and make sure I don't duplicate. So I went this way down. Now I could go this way down. So that's A, B, F, K, O, R. And if I keep doing that, I could count out there's 12 total ways to do this. I could go, and then I'd go like this way down, then I go A, B, G, L, P, Q, and then A, B, F, L, Q, R, A, B, G, M, Q, R. So I could keep going, and we could can count the 12 ways that way too. All right. Okay, now the last one. B is a point halfway between A and C. The distance from C to D is the same as the distance from D to E. Okay, So this is the same distance as this, and both of those are the same distance as this. So what they're saying is this, each of these is a third of the way, right? So this, if this is the whole way, if this is the whole, then E to C is 2/3. That's 2/3. This is 2/3 from here to here. And this here is half, right? The distance, point B is halfway between A and C. So this is half, and this is half of the whole. You don't know what AC is. You don't know what this distance is, but this distance is half of it, and this distance here, you don't know what FC is, likewise, but it's EC is 2/3 of it, okay? So that's what they're telling you. Now there's two ways to do this problem. One is kind of more geometric, one of them's kind of visual, or two ways that I've thought of. One is visual and one's kind of algebraic. So let's think of kind of the algebraic version, and let's use so this is 2/3 and this is 1/2. So I know if I just call AC a distance and CF a distance, I know that the formula for the area of a triangle is half of base times height. Okay, so if my base is AC, so I know that half of base of AC, the distance of AC, times the distance of CF, and technically you should be using, that means the distance, but I'm not going to go get super technical with my terminology here, my symbols. So half of AC times CF is 180. I know that. So if I know then, and so that's equal to, oh right, okay. So I know here that BC is half of AC, and I know that EC is half, no, is 2/3 of FC. Okay, so now my question is, so what is a half of BC times EC? What does that equal? Because that's the area of this triangle. A half of BC times EC. All right, well now I can do some neat substitution. Well, if BC is a half of AC, I can say, well, 1/2 times 1/2 of AC times, and then I can substitute in 2/3 of FC for EC. 2/3 FC equals what? Well, let's do a little bit of what we call factoring. So now we can reorder. If I say, if these things are all multiplied together, I can just say 1/2 times 1/2 times AC times 2/3 times, well, CF. We'll call this, sorry, CF, not FC. FC and CF are the same distance. Let me just call them the same thing that I was calling those pieces before. Okay, so now let's just regroup, because if everything's multiplied together, I can just regroup. So 1/2 times 1/2 times 2/3 times AC times CF equals what? Okay, well, I know that 1/2 of AC times CF is 180. So I know that this is 180. This is 180. So now what is 2/3 times 1/2 times 180 equals what? Well, half of 180 is 90. Two-thirds times 90, and 2/3 times 90 is 60. So our answer is 60. There's actually, so that's good. That's kind of a lot, but we're doing some pretty advanced math now. But there's another way to look at this one. And I didn't really see this one, but I looked at the answer, and it showed that, if you could draw a neat picture here that might help you see another way of getting at the answer. All right, so we know that ACF, we know that this whole triangle here is 180. Well, if that whole triangle is 180, then this whole rectangle here is 360, right? Because you can see that this is half. You can always take a triangle, a right triangle, and then you can make a rectangle out of it, and the rectangle is always twice as big as the triangle, because this triangle and this triangle are the same size. All right. So let's just start there. So we can make a triangle. So we can make this triangle, and because again this rectangle is 180, the whole triangle is 360. So let's just hold on to that for a second. Now let's make some lines. We know that this thing here is a third. This is 2/3. These triangles here, these rectangles here are exactly the same size, because this is a third, this is a third, and this is a third. Okay, let's do the same thing here. So this is a half, but what I'm going to do here is I'm going to make another half and another half. Whoops. And so these are all the same size too. Right? So this is the same, this is the same, and this is the same. And now these ones here are different sizes, but sorry, these are all the same. So that's the same, that's the same, that's the same, that's the same. And again, that's the same as that, and that's the same as that, and that's the same as that. So now we actually have 12 rectangles, and I didn't draw my lines perfectly, but these are all the same size. These are all the same size. So this is 1 unit, 2 unit, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And all of those are the same size. And if all of those are the same size and the whole thing is 360, then each of these boxes must be 30. So if each of these is 30, then this is 30, this is 30. So then this would be 30, this would be 30, this would be 30, this would be 30. So if we just now look at this square, or these 4 rectangles, the whole thing is 120, because we got 30 plus 30 plus 30 plus 30. That's 120. So half, if I draw remember, if I take a rectangle and I cut it in half as a triangle, then I have 2 equal triangles that are the same size. So this triangle must be 60, and this triangle must be 60. So that's another way that you can get to the answer of 60. So if you bear with me on all that, you did pretty good. You might have found, if anyone found an easier way to do some of these problems, feel free to let me know. But that's just kind of how I saw these problems, or how I solved them. Hopefully this was helpful. And if you have any questions about this video or would like me to do anything else, any other videos, let me know, because I'm always happy to help out.